Lesson 311, tenths and hundredths of a meter. The main focus in this lesson is for you to be able to estimate the length of a meter, for you to use a meter stick to explore decimals, for you to change measures in centimeters to meters, and to write measurements using decimal notation and make connections between various representations. Let's start with mental math and fluency first. Name all of the factor pairs for numbers such as these you see displayed on the screen. 12. What are the factor pairs? Remember, factor pairs means there's two of them. So what two numbers do you use to multiply to get 12? Well, you start with the number 1. 1 times 12 is 12. Now you go to the number 2. 2 times 6 is 12. Now you go to the number 3. 3 times 4 is 12. We're back to 4, so we're already turning around the numbers. So those are my factor pairs. 1 and 12, 2 and 6, 3 and 4. What are the factor pairs for the number 5? You should have started out with 1 and 5. 2 times nothing is 5. 3 times nothing is 5. 4 times nothing is 5. So what kind of number is 5? It's a prime number. And the final number, 21. What factors do you need to get 21? Again, start with the number 1. 1 times 21. Is 2 times anything 21? No. 3 times anything? Well, yes. 3 and 7, because 3 times 7 is 21. Is 4 times anything 21? 5 times anything? 6 times anything? And we're back to 7. So we've turned around now. So 1, 21, 3, and 7 are factors of the number 21. So is this a prime number or a composite number? Hopefully you realize it is a composite number. Look at the meter sticks that we have in our room. They are over on the 2-drawer file cabinet. Is your desk more than a meter long or less than a meter long? You shouldn't actually have to go measure it. You should be able to tell by looking at it. Your desk is less than a meter long. Now look at the computer desk at the front of the room. Is the computer desk more than a meter long at its widest point at the back or less than a meter long? Well, hopefully you can tell that it's quite a bit longer than your regular desk. So it is more than a meter long. So 1 whole meter. How many centimeters are in 1 whole meter? Well, if you don't know, it might benefit you to go over to the meter stick and to pause the recording now to get a meter stick so you can answer these questions. So a meter stick is 100 centimeters long. Well, how many longs would be in a centimeter then? Hopefully you're asking yourself how many centimeters are in a long, and you should realize there are 10. So how many longs would be in a meter? 10. What fraction of a meter is 1 long then? Well, you have 1 out of 10. And how do you write that fraction as a decimal? How do you write that fraction as a decimal? You would write it as 0.1. How many hundredths of a meter does this show? Hopefully you're realizing that it's showing 24. How would you write this as a fraction? 24 hundredths. How would you write this as a decimal? 0.24. I'd like you now to turn to Math Journal page 95. Math Journal page 95 is going to have you working on similar problems where you need to fill in missing information. Put longs and cubes end to end on a meter stick to help you. So as you're working through this, go grab the meter sticks, go over to where all your tools are for you to use, get approximately 10 longs, a big handful of cubes, and lay them out on the meter stick to figure out the length in centimeters, the number of longs that you're going to need, and the number of cubes you're going to need. If it gives you the number of longs and cubes, go ahead and lay them on the meter stick to help you fill in this information. The first one is done for you, so look at that one as an example if you need to complete this page. This is an assessment check-in, so when you are finished with this page, I need you to bring it back to me so that I can check it, and then I will make sure that you understand what you are doing. Pause the recording now and do Math Journal page 95, please. Thanks. Again, that was just the page you were doing. You should have came back to me to check out the rest of those answers. And now that I've checked Math Journal page 95, you are going to do Math Journal page 96. It reads, complete the second column table for centimeter and meter equivalencies. So it's telling you 100 centimeters equals 1 meter. 10 centimeters equals 0.1 because the 1 is in the tenths place. 1 centimeter equals 0.01 on a meter, which is 1/100th. So the 1 is in the hundredths place. So continue the pattern. If 1 times 100 is 100, what is 2 times 100? 10 times 100, 17 times 100, and so on. Finish Math Journal page 96, which is what I am showing you here to make sure you're on the right page, and then bring it up to me so that I can check it for you. Pause the recording now so you can complete that page. Hopefully you have brought it up to me before you continued on, and now you are going to look at this representation. It says represent each fraction and decimal amount on the grid and on the number line. So if I tell you that there are 3 longs to be placed on this grid, you would fill in 1, 2, 3. What fraction did you fill in? Well, of the longs, it takes a total of 10 to fill the grid completely. So the fraction on the bottom would be 10. How many did I fill in, or did I lay on top of the grid? I filled in 3. So 3/10 of the grid is covered up or filled. How do I write that as a decimal? Well, the 3 needs to go in the 10th spot. So I have 0 holes, but I have 3 in the 10th spot. How would I write that on my number line? Well, I can check. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, and this would be 10/10. So 3/10 would go and line up exactly with this line here. So as you can see, 3/10 of the line is not even to the halfway mark, which would be 0.5. So again, represent fractions and decimals. We just went ahead and did this on the grid paper, so I'm going to have you not do this right now. We will go back and do that though at a later date if it looks like that we need to. The papers that you're seeing here, the pages that I'm going through, are pages that are for the games that we play when it is game day, so we are not going to do that today either. In the number 724,191, the digit 1 appears twice. Compare the values of the digit by completing the sentence. I want you to go to Math Journal, page 97. This is the first math box instruction. So pause the recording now, go to Math Journal, page 97 so that you can do this with me. So the instruction is asking you to look at the digit 1 to the left. Okay? How many times as large is the digit to the right? So the digit to the right is 1. The digit to its left is 100. How many times as large is digit 1 compared to 100? Well, how does 1 become 100? You times it by 100. So it's 100 times, look at, there's the word even, times. So you're taking 1 times 100 to get it to go from the ones place to the hundreds place. Complete Math Journal, page 97. Be sure when you are finished with it that you bring the math boxes up to me so I can check them quickly for you to make sure you understood everything that you were doing on that page. So pause the recording now and do Math Journal, page 97. The final thing that you're going to be doing for this lesson is Math Masters, page 135. Math Masters, page 135 is just asking you to fill in the missing numbers. So they want you to look at the information that they have given you, and they want you to complete the pattern that's going on. Please make sure that if it tells you 0.01, that you are putting 0.02. Please don't leave out any of those numbers. Don't leave out the first 0. So this is 1/100th, 2/100ths, and continue on. When you finish with Math Masters, page 135, please bring it up to me. I will check it for you, and you are done with lesson 311.